Good.
So
So
have they given a range of values?
no range. Why will there be a range?
Because I got 2.31. I might have done
Ah,
something wrong. One second.
in the MS it is 2.3 only.
Yeah, I got 2.31 into 10 raised to 17.
Unit?
But I thought I was wrong because that seems very, very dense.
Density is very high for nucleus. This is the right range. In fact, and later on after the class, you can just Google density of the nucleus versus the density of a black hole. Nuclei are more dense than even the black holes. In fact, the nuclei are the densest in the entire universe. So you can later Google it up.
Sir, I got 2.35 into 10 raised to 17.
Fine. That is perfect. That's the right answer. For volume, what are we doing to find volume?
4 by 3 pi r cube, we find r using r is
Four.
equal to r naught a raised to 1/3.
And what's the formula for volume?
4 by 3 pi r cube.
Correct. 4 by 3 pi r cubed. And for radius, we use this formula.
Yes.
Great. So the first part is done. Now the second part. This question was placed in the tough category for revision village. So it is.
So for the next part, do we take 2.3 then as the density?
Yes, 2.3.
Okay.
But do we need that information for the second part? Let's check.
No,
Again,
we don't.
so work backwards. How are we supposed to find radius of the nucleus using this particular graph? Just a small hint, in the notes, we had done something called an electron diffraction formula. Does anyone recall the formula? Ahan,
And
Anishka?
does it have something to do with sine theta?
Yes, because it has diffraction in it, sine theta will be there. So let me write it down. So the formula goes like this. D stands for diameter. Diameter of the nuclei is equal to, or wait, no, let's start with sine theta directly. For diffraction, sine theta is lambda upon D, where D is the diameter. Now try to work backwards. Angle is given in the graph. Theta is 49. To find the diameter, somehow we need lambda.
So what is the value of Planck's constant again?
Planck's constant,
Yeah.
6.6 into 10 to the power minus 34.
Okay, thank you, sir.
But that's for a photon. We don't have a photon here. Which formula are you using?
Right. I don't know. I thought you could substitute the. Okay, wait, no.
That formula itself is valid for a photon, not not a particle.
Oh yeah, okay, wait, I got it.
But you are close. E is equal to hf cannot be applied, but there is a formula for other particles which have energy. Okay, so the concept is called de Broglie wavelength. So, Anishka, remember the formula for de Broglie
Yeah,
wavelength?
no.
Lambda is equal to h upon mv. Oh, so we do need the Planck's constant. So from this formula and use some sort of information from the data. Lambda is h upon mv. Speed, of course, is not given. We have been given kinetic energy. All right, check if anyone got it.
So I'm getting 1.74 into 10 to the power minus 17.
Okay, close. So tell me the steps.
I did h by mv
Mhm.
divided by sine 49.
First, what is the value of your lambda?
I got 2.50 something into 10 to the power minus 17.
Let me check. There is a small error there. So how did you find lambda?
I did the kinetic energy is equal to half mv squared and then found v and
What did you
then
find?
replace that. What?
So you found the m into v.
Yeah. I mean, no, I just found the v.
Okay, let me solve. What is m?
It's 56 into
No, no,
1
no,
point.
no, no, no. This is electron diffraction. Electron is being diffracted. So m is the mass of an electron.
Oh, right.
So it is 9.1 into 10 to the power minus 31 kilograms. 42 giga electron volts. Use this and find speed. So tell me speed first.
God, 1.2 into 10. No, that doesn't make sense.
1.2 into
No. I'm breaking the speed limit.
okay. So resolve.
I'm still getting 1.2 into 10 raised to 11, which,
Are you taking the square root?
yes, with the square root.
Okay, if your calculation is right, then which means data should not be consistent.
So
Oh,
giga is 10 raised to 9.
9.
Okay.
What did you use?
Use 9 only.
Okay, let's check. Anushka and Christine, tell me the speed. What are you getting?
So 1 second, I am also getting 10 raised to 10.
Oh, okay. So whatever you have got put in this formula, let's check wavelength because in the MS I can see lambda.
So for h by mb, we would take m as the mass of an electron again.
Yes,
So I have 3.41 into 10 raised to minus 26 is what I got.
that is wrong because in the MS, I'll tell you the lambda. It is 0.6 into 10 to the power minus 14 is what they have gotten.
Okay.
Let's see. Christine, what are you getting speed as V?
Sir, I also did not get the right answer.
Okay, which means there is an issue somewhere. Let's see.
Sorry, how is our mass 9.1 into 10 raised to minus 13?
13? No, minus 31.
Yeah, why is
That
it
that's
31?
that's the mass of an electron.
Okay.
So you're asking why is the mass of electron this much?
Yeah, I mean it that's probably why our answers are so big because of the 10 raised to minus 31.
Hmm.
Or that the giga is wrong, but the giga is correct.
Okay. The kinetic energy
So,
given was 42. Yes, Krishna.
is there another formula for momentum or something?
There is another formula, but it comes from this only. Let's use
Okay.
that. Then we'll compare. Okay. So first of all, momentum as we know is m into v and kinetic energy is half mv square. So there is a formula which connects these two, which is the momentum is square root of 2me. Do one thing, let's do this.
So could you just tell us what the final answer is?
Okay, final answer is fine. Okay, so the question is to find the radius. So diameter needs to be divided by 2. Final answer is 4 into 10 to the power minus 15. Are you getting that?
Oh, no.
Okay, fine. Let's use this formula and then we'll compare with the standard. Root of 2me. Solve this and tell me the momentum. This will give us an idea where are we going wrong. Right? Anyone getting this momentum?
Sir, one question.
Mhm.
The mass of an electron we take for only one electron?
Yes, one electron.
Okay.
The momentum as 1.11 into 10 raised to minus 19.
That is correct. I mean, according to the MS, that matches. 1.1 into 10 to the power of
Minus 19.
minus 19. This
Sir, I got that
matches.
as well.
Okay, now let's put this value over here in the momentum, mv, and find lambda.
Sir, is it 5.9 into 10 raised to minus 15?
The wavelength?
Yeah.
Yeah, I got that
No.
as well.
5.5 into,
5.9 into 10 raised to minus 15.
let me check. It is correct. Good. That's the lambda. Now use the diffraction formula to find diameter and then divide by 2. Be careful, the angle is in degrees.
Yeah, 4 into 10 to the power minus 15.
Yes, that is the
Yeah,
final answer.
3.94. Yeah.
So
We
approximately
should
4
get
into,
it, right?
of
Using
course,
kinetic.
yes, because this formula is derived from this equation. Why are we not getting it? So can you resolve? Uh,
Sir, I did. I got the mistake I was doing. I was multiplying electrons with the number of electrons. So,
oh, okay. So are you getting the momentum the same from,
yeah, I did. I got it.
which means Ahan and Christine, are you making the same mistake?
I must have, sir, because I'm doing it on my phone
Probably.
calculator. So,
Okay. You are supposed to get the same answer because it's the same formulas which we are using. Chalo, fine. All right. So for now, today's session ends. Now what we will do is, okay, before we end, Remember, we were doing chapter 12 revision. 12 chapter consists of two subtopics, 12.1 and 12.2. All the questions which we have done today falls under 12.2, right? So now your homework is, if you, whenever you revise, go into revision village. I have skipped all the theory based questions. So please solve all the theory based questions, right? And
All right,
some
sir.
questions still are there which we haven't attempted. So solve the entire thing, 12.2. Tomorrow we'll focus on 12.1. All right. And tell
Sir.
me, all of you have school tomorrow?
Yes, sir. But it ends early.
Okay. See, the issue is for this week, I am not in Mumbai. So next week for next week only, it will be online classes for Monday and Friday. Tell me, can you attend online tomorrow?
Yes, sir.
Yes, sir.
Yes, sir.
Can we keep it at regular 4:30 online?
Yes,
Yes,
sir.
sir.
Yes, sir.
Anishka, what about you? You need to travel
Yeah,
back.
yeah, works.
Fine, 4:30. We'll meet tomorrow online. Okay, see you then. Bye bye.
Bye,
Bye,
sir.
sir.
Thank
Thank
you.
you.
Bye, sir.
Bye bye.